Yeah.
realized I stole one of your pens a long time ago and I still have it.
Oh, it's one of my blue pens?
Yeah. The
Oh.
special ones.
Are you gonna grade with it today?
No, I was gonna give it back, but now I'm good with it.
Fine.
Now that you offered.
Wait.
But yeah. I think you probably need
Are there
needed
forks
this.
or no?
There are forks in my cupboard you guys can get out. They were supposed to bring.
Oh, no, I have some. Yeah, I just saw the spoons. I was confused.
Theoretically, they brought both.
Got it. Okay. Did anyone do 16
Yes.
real quick?
I wasn't able to check it.
5e to the 5t over 1 over t. The t moves up to the top, right?
Yes.
Because Slater said stay on the bottom.
Yes,
all
if
over.
he's looking at the comment Slater, it's wrong.
Okay, because I just didn't finish it because I was confused.
I didn't look at first, so my problem was wrong.
Make this instead of the
Okay, well, I just wanted to make sure, I didn't want to do B if A was wrong.
Yeah, and you know when Slater's
and
wrong.
then make
Yeah, because I was like, wait,
Thursday.
Because I don't have a Slater account, I can't
Oh,
comment.
you
There was
can
already a
put in-
comment there that said.
well, you can put in answers?
If you have an account,
Do Thursday.
I don't think I have.
I used to do it, and then you get gold,
Yeah.
and then if you get a certain amount of gold, you get money.
Actual money?
And then tomorrow, yeah, that's
Wait,
good.
really?
Yeah.
Chapter 5,
Yeah, but you
review.
need a lot of it, yeah.
Test
you need a
tomorrow,
lot of
good.
gold.
7, 8.
That's what I was trying to do for a while last year, but I couldn't get enough ratings or whatever. No, I was like, whatever.
And then
And
put
then all the
fighting.
pre-cal kids would look at my assignment, like look at the answers I put up,
Mhm.
and then they would take pictures and send it to me like, oh my god,
And then I
John."
collected the
And I
37
was like,
today.
yeah, give me a good rating so I can get my things, and I didn't.
So it's
Now
really
the books got, now they changed the books, like, I think we're
Let's erase
Yeah, she-
37, because we'll do that for
No,
tomorrow.
it's the same female book.
And
Oh, it is?
instead,
Then it should
put
be same me again.
quiz corrections, but chapter 7 quiz corrections, and then Pi Day activity.
All right, cool kids. Let's go ahead and. Sorry, Joyce. Hi. We've been getting logistical stuff.
What's up, Joyce?
We're recording?
We are
Oh,
going
shoot.
to.
Hi,
I
Joyce.
know. Hi, Joyce. Make sure you get food, Joyce. Even though it's AB kids, I think someone's bringing a calzone in period 6. That's awesome. Anyway, so far the best thing today has been like a fruit tart thing this morning. I totally stole the leftovers. All right, so.
Are we really doing
Oh
this?
no.
Blackberries, and if you guys have this for tomorrow, it's a bonus. George brought something. Who else brought something? Didn't someone bring like a soda or something?
I brought a soda.
Okay, so Gerardo brought bonus and George out brought bonus for the test category, and this is bonus for the homework category.
Yeah.
Do you guys hear that?
Yeah.
So bonus bringing in food was for the test category, and then bonus doing that by tomorrow is for homework category. The Pi Doku, read the directions, it'll really help. If you don't read the
Yeah.
directions, you're gonna be lost.
I just looked at it and that looks really fun.
Because it has the numbers 1 through 9 and 3 pies, and it's by row, column, and segmented jigsaw piece.
Is that what you're asking? Is that what you're
What the
asking?
cuss? What the heck
They-
is this?
Read it. Every row, every column, and every segmented jigsaw piece. Because they wanted to put a pie in the middle, so they didn't just do squares. Okay. Joyce, make sure you get a worksheet. It's the same one that period 6 has. Before we go over homework questions on 11.1, I want you guys to tell me how to solve for the following. Ready, set, go.
4t cubed minus 6t squared all over 2t. There I am.
Misty, what if cleric is a real word, isn't it? Is cleric a real word?
Cleric?
I think a lot of those are real words. You mean the anagrams?
Well, I mean, like, cleric, it's supposed to be mixed up, isn't it? But
Yeah.
It's a word.
Cleric is a word.
So maybe there's another one.
Yeah, there's another word.
It's circle,
Like,
dang
is it these?
Circle.
Oh, thanks for the answer, George.
Works?
Appreciate it.
Those, no, those words are for the word search, and then on the back it just has something to do with pi, like cleric is circle. Dun dun
So
dun.
that means that one of these is circumference. Oh, there it is.
Hold on, how do I find second derivative though, because we're not done.
That whole thing,
Yeah,
derive it.
And then times 1 over x.
don't you guys just love telling me what to do?
So, yeah,
Derive
wait, ready?
Should I
So-
cancel stuff?
Yeah,
Yes.
pull out some 2's.
Okay, so I can have 2t squared
Oh, yeah,
minus
plus
3t, but t cannot equal 0, right?
You.
That's the one way to maintain the denominator of t. Otherwise I'm good. So now what?
That makes the deriving easier.
Yeah, see? I was being lazy.
The derivative.
So Amanda was saying derive the first derivative, and then anything else?
Divided by
2t.
X prime, good, 2t. So then I have 4t minus 3 all over 2t, and then t doesn't equal 0, but it still can't equal 0. Now what?
The limit equals 2.
Not the limit. The derivative equals?
1/2.
Uh-huh. So question, what sort of concavity does this path have?
Concave up.
Concave up, okay, cut. So if the first derivative at 1 equals 0, which it doesn't, and this was concave up, what sort of relative extrema would you have?
Minimum.
Okay, let's check our homework. You guys ready? Evens. There we go. At 11.1. What's the first even that we came to?
4.
Oh, on? No, it's good.
4?
4.
Yeah.
Oh wait, that's exploration. Sorry, I was like, that's weird. I don't think I assigned that one.
Better be sorry.
4. The first question. Well, actually, you're supposed to sketch it, and I think you were supposed to show the orientation. No, they didn't make you show the orientation.
We were supposed to.
Yeah, we were supposed to, but they didn't do it on the answer.
Oh, well, that's dumb. What was the orientation?
Like that.
I know, but which way was it going? Was it going down or was it going up?
Uh-huh.
It was going down. Okay, so the little down arrow.
I totally do that.
Is y a function? They were asking if y is a function of x, and the answer is no, because it
It's not.
Oh,
it
I
doesn't pass.
get it.
fails the vertical line test.
Yeah.
Then they said eliminate the parameter. Now, some people didn't have me for pre-cal, and I didn't explain it. How do you eliminate the parameter for
Solve for
parametric?
t and plug in.
Yeah, but probably which one should you solve for t for?
The easier one.
X.
X.
True.
Solve for t in terms of x, plug into the y, and then you have y as a function of x. Done, done, done.
Did I write that wrong?
Bless you.
Thank you.
Something magical happened? What was the problem in number 4?
Wait, yeah. Wait.
Okay, so x equals sine of t, and y equals 2 cosine t. I know there's a thing where you plug it, but that's not what I did. and That's
How
not
do you
fair.
solve it? X equals what?
Oh,
Sine t.
yeah, this will stop me too, and then let's later.
Y equals? No, we
2
did it
cosine t.
pre-cal last
2
year.
cosine t.
Or the rest of you guys 2 years ago. 2 cosine t?
Or for them, like over summer, so they didn't do it out there.
Yeah, never did.
Oh,
That was the
it's
thing
easy.
you
You just
plug
square it. Divide the 2 over,
See,
square it.
cosine squared plus sine squared is 1. So if we can get 2 cosine squared plus 2 sine squared and set them, and add them together, then we can get equal to 1 and the trig disappears.
So would it be illegal to say y equals 2 cosine sine inverse
So we
x?
multiply by 2, multiply by 2,
Square?
and then we can square it, and we can square it, and we can square it, and we can square it. And we end up with
Divided by 2.
4x squared equals 4 sine squared, right? And then y squared is equal to 4 cosine squared, right?
I think we divided by 2.
Hold on, it's fine. And then we go ahead and say, hey, can we add these two together, 4 cosine squared plus 4 sine squared?
Yeah.
But to do that, we have to add the other two together. So we have 4x squared plus y squared is equal to 4 times cosine squared. See what I mean? Sine squared. What's cosine squared plus sine squared?
1.
The t is gone. The perimeter has been eliminated. All we have to do now is divide by 4, and we end up with x squared plus, technically if we were in pre-cal, we would do that in order to think about our conic sections. And this would be an ellipse with an x radius of 1 and 1, a y radius of 1 and 2 and 1 and 2, and this would be our shape. But because of what they gave us as far as our 2 points, we only did it for limited intervals, therefore we only had this side. Gerardo, go.
Couldn't you have just made your life just a tiny bit simpler and x equals sine of t, y equals 2 cosine of t? You could have just squared both sides. Well, for the y,
I
divide by 2
suppose,
and
but
square
when
both
I add
sides.
them together, I wanted to have them have the same coefficient. So I don't think that would necessarily be easier. We could have done what George said, which was divide by 2 first, then square both sides.
Yeah, that's it.
Oh, you said just square both sides.
I stopped and divide by 2. As a side note.
I followed your original logic. Both ways work. I kind of like dividing by at the end, but that's just me. Okay, next one. 16. Are there any odd questions in between?
Oh, for questions? No.
I didn't.
Okay. Number 16. A is 5t times e to the 5t.
Okay, and then b.
And then b is 25t squared e to the 5t plus 5t e to the 5t. Product rule.
Yeah.
Yeah, I
I
didn't.
factored a lot. It's okay. It's probably the same thing.
I don't know.
You could have pulled out a 5t and you would have ended up with 5t, actually 5t e to the 5t
Yeah.
times 5t plus 1?
Yes.
Yes.
Wait a minute. How did I get 5t plus 10? Well, no, not that, but like the coefficients, I got 5 and 10.
5 times 5?
You probably did 5 times 2 instead of 5 times 5, or 5 plus 5.
Coefficients? Yeah, it's 5 times u prime.
Second d first.
Mm-hmm. Plus first d second, and you need your times u prime, which is 5, and 5 times 5 is 25.
Okay, so it's e to the 5. Oh, shoot.
There you go. Number next one. Any questions on odds
Oh,
between?
you need 25.
25?
Is that what you said?
25t squared.
Oh.
19?
Shoot.
19 question?
Yeah.
Okay.
Alright, so I didn't know how to do it mathematically, but
Yeah, I
I
didn't
could
know
look
how
at
to
it. I could look
Oh.
at it at the graph.
Yeah, this one was interesting. I
didn't know
looked on this later.
What was the question? What'd they ask?
So
Find the rightmost point.
yeah.
So,
when x is the
min,
furthest
but
Well,
it's
were you supposed to
side.
find the path first?
Yes. So once you did that, and then you
What's
sketched
your
it,
at the rightmost point?
it is when x equals or
It
y
could be
equals
a 0. Y could be 0.
You
Oh,
could
it's a
do.
it's a
You
vertical
could do.
tangent.
Yeah, you could do when y equals 0 and dy dx is undefined,
Okay.
right?
Yeah, but here's the thing. dy dx is never undefined.
Well, it would be when
What was
cosine, it would be
dydx?
pi. Well, oh no, cosine.
It's 2 cosine t over
Oh, no, it
negative
might be.
sine t.
Wait.
So yeah.
that's fine. I'll
Sine
save
can
it
definitely
as-
equal
as a
0,
variable I
right?
got. 19?
Yeah?
I didn't do the second derivative.
Oh, I was looking at 20.
I didn't do second.
But this is the first derivative, right?
Oh, duh. I was
had
looking
it
at
flipped.
20 for some reason.
Did I do it wrong? Hold on.
What were your original functions? Y
X
or
equals-
x equals?
Y is cosine t.
Yeah, and then
Oh, yeah, I did it upside down.
x is 2 sine t.
Couldn't you just maximize x, and that's the furthest point out? So you just take the sine chart of the x derivative and make life just build more simpler.
Sorry, the negative sine t.
And then yeah, over 2 cosine t. And then so the second derivative would be bottom d top minus top d bottom.
Or you could do negative 1/2 tangent.
Okay, yeah, negative 1/2 tangent and the derivative of tangent is secant squared, right? And then times 1 over cosine. which
Oh,
is
for the
3
second
minus-
derivative? Do we need to find a
secant
second
cubed?
derivative?
Well, don't we define when? Oh no, so when it's undefined. So
So we can just take this one and when it's
Pi over
cosine
2.
0, cosine 0,
Yeah.
pi over 2, 3 pi over 2, et cetera, but we
But,
don't just want when cosine is 0.
well,
We also want when y is 0.
so y equals 0.
Oh, but we're looking at the first positive value though, right? What I was saying is cosine is 0 in many places, but do we care about the ones that are beyond or the ones that are before? Probably not, but to double check just to make sure we're on the right one.
This hit is often so.
Cosine is 0 at pi over 2. At pi over 2 is y 0? The answer is yes.
But that's not the answer.
Misty.
Pi over 2 is not the answer? Oh, they said the point though, that's just t.
Yeah.
Yeah.
Oh, and then we plug in.
Yeah, so
Okay.
t is equal to pi over 2. Then we
2
plug in.
times 0.
So then we have y is equal to 0 and then x is equal to 2. Gerardo also brought up a good point in the sense of if you're trying to find the rightmost point, you could just maximize x, so you can take the derivative of x. But you have to take it d dt, some of you might get a little confused on that. So x prime would equal 2 cosine of t and then figure out what's the maximum of cosine.
Pi over 2. Pi.
The maximum of cosine is 1 at pi over 2. So you could have also gotten t equals pi over 2 then as well. Does that kind of make sense?
Mm-hmm.
So if they were saying the uppermost, if we have a picture, we could probably identify it and figure out a
Oh.
clue, but we could also just maximize the y.
I even had the t equals pi over 2, but I didn't plug it.
Oh, yeah, if you're x and you're y.
Were we supposed to use a graph here, or were we supposed to use a chart? Because I feel
At
like,
this point-
Technically, couldn't you do both?
yeah, I feel like they
How
use
would
graph
you
for
use a
that
chart?
exercise. You have the
T's, X's, and Y's.
Yeah, and then you use unit circle values because you have cosines and sines.
It's just these, I should use
Yeah.
But you can do it with the table, and you're
two.
totally right.
Misty,
See?
do you happen
Yeah.
to have a big red pen? So I have 2 big pens and a paper mate, and it's bothering me.
I don't use red pens. Lo siento. Okay, number next
Red
one.
is me, right, Miss T?
Huh?
Yeah,
Red is me, right?
Yeah. Green is supposed to be calm, but then it's never dark enough, so that's why I switched to blue. Either way. What's the next odd that we have? Or, sorry, odd question or even number?
On the 6, they're even. I don't know if we have.
No.
So,
A is -2, -2, and -2, 4. B is -5, 1, and 1, 1.
I mean, who are
Can we do this one? Alright, I'll do this one.
Oh, schmuck! I put at time.
Okay, we're taking a derivative of y, derivative of x, and then we have our dy dx. If we're thinking about when what was the first one? Horizontal tangent?
Yes.
Horizontal tangent, our derivative has to equal 0, which means our y prime equals 0. They just went ahead and set the top of the derivative equal to 0.
What was
The derivative would have been 3 cosine t over -3 sine t. So then set cosine t equal to 0 when
And
the
when
top
is
is
it?
equal to 0.
And what is the top? What is the power of 2 plus pi n, right?
They went ahead and cheated just a little bit because they're just looking for x and y. And remember, on a path, something might go on a path multiple times, so t could equal multiple values. But they were just trying to think of what happens if cosine is equal to 0. And then they went back and they said, if cosine is equal to 0, plug in 0, y is equal, sorry, is that x? That's x. If cosine is equal to 0, they just went ahead and plugged in, because they're like, oh, hey, cool. So 0, so x is -2, and then they plugged in if cosine is 0, sine is either -1 or +1. So they plugged into y, and that's how they got x is equal to -2, and y is equal to either -2 or 4.
Did they ask for the point or for the?
Oh, I don't know. Did they have the directions written down on that?
Find the points at which the tangent line,
Point,
yeah.
I just said find the tangent line. Hello.
Now, could you have solved for t and gotten multiple angle values and plugged in those multiple angle values? Yes. Did they shortcut the process by plugging in the trig and then using unit circle knowledge? Does that make sense? And then for letter B, same dealio, except for letter B, you're setting the bottom equal to 0, which would be r -3 sine of t, which is gonna occur when sine is equal to 0, when sine is 0, cosine is 1 or -1, and that's how we get by plugging into the original.
74.
But you have to admit that was creative. Like, I don't know if I would have thought of that. I probably would have gone
I
looking
did
for
it.
angles. I would have gone looking for angles.
If you guys notice, x equals ln of secant t plus tangent of t, that is the answer to the integral of secant. Integral of secant is ln absolute value
We
secant
didn't
plus
have to.
tangent. So you can just derive and just put secant. And then minus derivative of sine, so it's secant t minus cosine t.
Alright, I thought this
You
was
can
easier
derive.
calculator.
Why are we deriving, bud?
Because the derivative of x is secant t. You could like know that, okay. The
Oh, you're
integral-
just solving. You're just solving. So
Yeah,
when
yeah.
we plug into our formula, we end up with, right, arc length. We have x prime squared and y prime squared. So then when you go ahead and do x prime and y prime, one way to do it is to use your trig properties, and using your trig properties, you'd actually have to, you could do it a couple different ways. You could FOIL it. You could think of secants and cosines, like for instance, if you multiply secant times cosine, that's 1. So you would have secant squared minus 1 would be -2, because the secant cosine would cancel. And then you would have plus cosine squared plus sine squared. Cosine squared plus sine squared is 1. So then we have 3. Cosine squared plus sine squared is 1. Oh, 1 minus 2, that'd be a -1. Secant squared minus 1 is tangent squared. It was a lot of trig.
I think we were allowed to use a calculator,
Yeah, we were, I did.
so we just plugged in. I got it.
You were?
They said for an algebraic challenge, do it by hand, and I was like, it's 10:30.
What did I intend? The algebraic challenge. Punks. Anyway.
It was 10:30.
But did you follow the logic of what to do?
I mean, I could.
FOIL it out, secant and cosine will cancel the b1s,
Yeah.
you're gonna have cosine squared, sine squared, which will cancel the b1s, you're gonna have secant squared minus 1, which is tangent squared, square rooting that is just tangent, you have your ln, and then you plug in your top and the bottom. Party poopers!
You're welcome.
Okay, what's the next one?
30, well,
Oh,
37 we have problem
Can we
on,
do
48.
Okay, 37 problem one, then 48.
and then
37
48,
doesn't like
and
me.
50.
37 is evil.
That's it?
Ha.
I didn't really look at the question, but.
What was the problem? What were they asking? Son?
so if it says the parameter is x, that means instead of t, it's x?
Mm-hmm.
G.
So in
The
terms of
parameter
x,
is t, usually.
in terms of x, yes. Yes. What are we on? 37?
Yeah, we're right there.
Do you guys know why I asked you this question?
That's a good AP question.
It's gonna help us, something.
Because both of these find arc length. One of them is when you're in terms of x, and one of them is when you're in terms of t.
Oh,
dough.
Does that make sense? So in this one, if you're in terms of t, so showing how one reduces to the other. You're trying to cancel out the dt or think of it in terms of, so you can say x is equal to t, is that how they went about it? Yeah. X is equal to t, which means x is the parameter because, I don't know why that's open, sorry, Luciano, get rid of that. And this one, you're dependent on x is your parameter, so you can just say, hey, so what if t is equal to x? What if there is no extra variable, so you have dx, that's just a 1. Replace with x, that's dy dx, got it. Replace with x, that's dx. Dun 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 dun.
So I still don't understand. You just replace x.
And this second one, y is a function of x. You can think of it in terms of, you can make any function. Let's think of it this way. Okay. In this one, you have y equals f of x, right? And this one, you can say, oh, from this, I can say then x is equal to t, and y is equal to f of t. Don't these say the same thing?
Yes.
Perfect.
So you just.
So then in order to go from one to the other, we can say, oh, okay, well, if x is equal to t, then I can just plug in an x and an x and an x and say, oh, sweet. Dun, 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 dun.
X, dx is, ooh.
Right? dx and dt are equivalent. So I can plug in, and simplify.
So it would be dy, no, it would be d f of t over dx. It would be just dy,
dy.
yeah, duh.
Yeah.
Pretty
yes.
much.
So we can go from any function to parametric, but it's just going to be a basic parametric. It's not going to be with different periods and that sort of stuff. But okay, and then our next even was 40. Sorry, I got lost. 48. C.
What? Yes, what? You don't speak Spanish, right?
Any other evens or questions on odds?
50.
Wait, so I'll eliminate the parameter, so like what you did before?
Yeah, but you can think of it in terms of if y is cosecant and x is sine, cosecant is 1 over sine, so I can just plug in 1 over x. Yeah, you really have to sometimes think outside the box in order for these plugging ins.
Outside the parameters?
Ooh, look at you go.
Think outside the button.
And then they thought through the signs of sine and cosecant.
Or can you just say because of the 1 over x?
Yeah, or you can just take the first derivative, second derivative of 1 over x. Both ways would have worked, right? 50 is D. Is that what you guys said was the next one?
Yeah, but I have a problem with that.
Okay. Anybody else have a problem with that?
I had everything is exact except it's the first one minus the second one in the answer, but I got plus. Like you see how there's a minus there? I got plus. That's what the formula says.
Well, if you look at your thing, is it plus negative 6 sine t?
Yeah, but that's
Oh, no, that's
in the
squared
squared.
number.
So that's where my bubble comes.
My ball.
That's a reference to this movie with Don Cheadle and Sylvester Stallone, Demolition.
What do they say the final answer is? D?
Yeah.
Is traversed exactly once as t increases from 0 to pi.
The burger thing's today, right? Oh. Oh, and Ms. Zuck said that she doesn't go to the thing because she wasn't invited. And I was like, oh, so ASB has to invite you. No, student council has to invite you.
No, we talked about that.
Yeah.
She's gotten invited.
She likes to say that to the classes to let you guys know that she cares about you, and she's gone in the past and she's like, oh, it'd be fun, but she's kind of just making a joke of it, if that makes sense.
Is that like
Why can't you just say I don't want to go?
It might be more complicated than that. I'm not exactly sure what the more complicated is. What she would like to do is not what she would need to do, if that makes sense. So she's explaining to you guys, oh, I'd love to go and hang out with you guys and I'd do this, but that's not the job, and so I think it's kind of a, anyway.
49 is
It's
C,
okay.
right?
Just let you know, like, oh, we love you, Zach, and then just leave it there.
Just
Okay. For number 50, sorry, did anybody figure out why there's a minus?
What's going on?
Jackie, do you know?
I think it has to do with the traversed only once. But they literally did absolutely nothing for that problem. Because the formula says x prime squared and y prime squared, right?
Yeah, but it's plus, right?
Would the book have an answer, Misty?
Ooh, it might. I forgot we had that for this class. We don't for AB. Okay. Do we have any other evens or odd questions besides number 50? Going once, going twice?
Gone.
Sold! Alright, everybody all together. We are, I'm coming back to this, I promise. Going on to vectors.
Oh.
Ready, set, go. New section, new side, 11.2.
In that case, can we bathroom? I'll write this down.
Write it down first, then you can write that.
Misty?
Huh.
So it says words may go up, down, left, right, diagonal. It does not say backwards, but I found Greek backwards.
It did not say backwards?
It does not say backwards.
We found Greek
Oh.
backwards.
Did anybody find Greek going the other way?
No, I found it backwards.
Yeah, just do the backwards, that's okay. 50 literally says D. Huh.
oh, those fucks. I have no idea what they're talking about.
I would agree with the plus, and now I'm confused. I'll have to look at that one. 15 and 11.1. I'll check it out because I honestly don't know how to answer questions.
Do notes.
Okay, you guys know how Miss Goodwin had us do
Wait,
journals?
are you ready?
No.
Yeah, I'm ready.
I saw you looking back here. Now you may talk as long as you're ready.
She had us do journals.
The only one that's
In,
in there is that.
I'm aware. But freshman year, she had us do journals. So, see the backstory. This year, she's having her regular classes do journals. But today, the journal started with, do you think? And as I was writing it, I was looking through my paper because the light was right on top of it. And the paper right under it had started with the words, do you think, like, right, word for word.
That was a good story.
That's all really sarcastic.
I would assume she is. Did you think it was a good story?
And, you know,
I was just commenting on the perfunctory of everyday life in this movie.
the what?
Perfunctory means like just something you do every day, like just like you just do it like on an autopilot. It's just you don't even think about it. I learned that word in the 8th grade, day 1 of U.S. history.
Go team.
Did I really?
Okay. Now, kiddos, this section on vectors can be, how should I say,
Ugly.
as easy or as hard as you make it. Meaning, it is not meant to be hard, but vectors in and of themselves, in the physics sense, can be quite involved. But, oh, do we not have it yet? Sorry, a couple more seconds. Sorry, Joyce, hopefully you paused it because I was going quick to show them the book. Her view is quite different than your guys' right now. I froze the screen for you guys.
Oh, dope.
Alright, you got it? Boop. Okay. In pre-cal, so first, I'm saying this for those of you that did not have me for pre-cal, aka Adeb, Amanda Johnson, and Joyce. Did Joyce have me for pre-cal? She didn't, right? Okay.
You probably had Leon.
No.
Lucky you left.
She did the skipping thing too.
Oh, Sam had Leon.
Long story short, focus. Long story short, yes, Sam had Leon. This section is going to go all the way to the beginning of vectors, even though in pre-cal we did cover vectors for basically an entire chapter. So I don't want to go over all the things like, hey, it's a directed line segment. Hey, there's an arrow, but it doesn't mean that it's an infinite ray like in geometry. It just means that it's pointed this direction. It could be a force. It could be a speed. It could be, what else could it be? Force, speed,
Acceleration.
just length. It could be a speed of a speed like acceleration, etc. So this arrow just means a directed. It talks about how you can talk about vectors in terms of component. You can talk about them like Despicable Me says, which is a magnitude and a direction. You can talk about vectors different ways.
Oh,
It goes back to exactly the magnitude of a vector being the square root of a squared plus b squared, which is how much there is to the vector, not just its magnitude and direction. Draw it up quickly.
Amanda hasn't seen that scene.
Oh no! Maybe tomorrow.
Oh.
It also goes through and talks about the direction angle, the terminal point, which is the ending, the initial point, which is the beginning. I think it even talks about how you can add vectors, head to tail. There's a lot of stuff with vectors that goes together with physics. For instance, you guys were just writing down this, right? If you need to label things, you can label things like the point from which a vector originates is called the head or the initial. The arrow at the end is called the tail or the terminal. Wait, I said that backwards, didn't I? Head, tail, tail, head. Why am I confused right now? It's been a long day.
The arrow is the head, right? And then the tail would be where it starts, correct?
Because it's what comes behind, right?
I believe so.
Yeah. I said it backwards, but this is the initial point or the tail, my bad. And then this is the terminal point, the final point, or the head. Awkward. But we can break any vector down, any diagonal vector down, I guess I could say, into its horizontal and vertical components, hence why you wrote V with a little directed arrow above. You can do a two-sided arrow, but I think that looks too much like geometry, so I just do a one-sided arrow. That's pretty common. And we can say that a vector has a horizontal component and a vertical component. For our purposes, we're going to say x prime of t and then y prime of t. Because if v is a velocity vector, which is what we're talking about, we're specifically applying it in calculus to velocities. If v is a velocity, then its horizontal vertical must be the x prime and the y prime. And then if you think about it, what would the slope of this vector be? Y prime over x prime, which is the same thing as dy dx, slope of the tangent line. So a lot of ideas come in together. Your book, I'm going to put some things in your homework having to do with like pre-cal-ish ideas or introductions to vectors. So those of you guys that are not familiar with it, feel free, go back into the section. They give a lot of detail, like I was just showing. They give a lot of detail and they work out some of these examples as well. They even talk about vector operations, how to add, how to subtract, multiply by a scalar, etc. But let's just talk through these pre-cal-ish ideas real quick. Meaning, help us out. You know it's a vector, bless you. Bless you. You know it's a vector when you have side carets, right? Instead of parentheses, you have side carets. If we were to talk about this vector, if they don't give you an initial point, you just always start from what point? 0, 0. Then you can think of, still think horizontal, vertical. -1 would say go left 1 horizontally, go up √3 vertically. And then we would draw a vector there. So if you want to think about the vector, you can think of it with -1 as a horizontal component and then √3 as a vertical component. What are they asking for if they ask for the magnitude? Do they want it broken up into horizontal, vertical? Or do they want it all together? All together. Now, what are we going to find if they want it all together? We signify with absolute values. Absolute values around matrices mean determinants. Absolute value around vectors mean magnitudes, aka the length of the hypotenuse, aka Pythagorean theorem.
AKAs.
Oh, it's not 47. So then 1 plus 3 is 4 and square root is 2.
Ah, okay.
47?
AK-47.
Oh.
So the magnitude equals 2. This notation would be the absolute value of the vector v. Direction angle. So magnitude is going to be the length of the hypotenuse, or the length of the vector itself. The direction angle will be usually from standard position. We could do a compass bearing and make north, south, east, west, and do like Girl Scoutish stuff, but we'll just say normal direction. How do we find an angle if we have an opposite and an adjacent?
Cosine. No, opposite. Yeah, opposite.
So we can use tangent. So we can say tangent inverse of
1 over √3.
opposite over adjacent. But I think you should know what this guy is. Isn't this a 1√3 triangle?
Should I really know
Yeah,
that?
it's a 60-degree.
It's a 60-degree in the second quadrant.
Negative.
Shoot, I'm screwed.
So,
Well, just think of it this way. Isn't it the tall one?
mhm.
The little one would be a
Oh,
30
wow.
degree-ish, the middle one would be a 45 degree-ish, this one is a taller one, so it's a 60 degree-ish. 1 pi over 3, 2 pi over 3. Pi day! Hey, it's important to know your unit circle.
Is it okay if I just got that by dividing by 2, so it's 1, so 3 over 2, negative 1/2?
If you got there, that's fine.
For some reason, I did this thing to look at the thing, and I was like, what does this one look like? And then I was like, oh, the drawing's
It's okay, I can tell you were visualizing.
right there.
What Gerardo was saying is that that's a length of 2, and so he just scaled it back to a unit circle, so root 3 over 2, negative 1/2, and thought about that.
Awesome.
Okay, so that's pre-cal-ish, although some of you might need to look in the section for the pre-cal-ish stuff, yeah? But vectors, we have instead of parentheses, little side carets, they're directed line segments symbolizing possibly speed. What if they give us a magnitude and they give us a direction angle? How do we find the component form?
Is this where polar starts to come in?
Let's get in there. So we can label this as 3, we can label this, that's 11.3, as 40 degrees. What do they want if they want it broken down into components?
X and Y.
Yeah. They want over here broken down into knowing the horizontal, knowing the vertical. They want it broken down into that. So just think about finishing the right triangle. So we're gonna find our x component, we're gonna find our y component, or since we're using x and y to symbolize like parametric equations, you could think about it as a and b, that might be a little bit easier. So vector v is gonna equal a and b. Thinking of right triangle trigonometry, well that is trigonometry, how are we gonna get a? We know an angle and we know hypotenuse and we wanna know the adjacent, right? So which one uses hypotenuse and adjacent? Cosine. So we can say cosine of 40 is equal to a over 3, so a is equal to 3 cosine of 40. In physics, you would memorize something like the horizontal component is a cosine theta. Or, I'm sorry, is magnitude cosine theta. B is equal to magnitude sine of theta. Using similar logic with sine of 40 is equal to b over 3, solve for b. Are we kind of keeping up with the trigonometry stuff? Okay. How would you solve? Whatever, plug into your calculator, right? Let's start doing some calculus-y stuff. Woo! Intro to vector calculus. Nice thing is, this is one of the least covered topics in CalcBC.
Is that a bad thing or is that a good thing?
I don't know. I think they're basically saying this isn't physics, so we'll just get the basics, which is okay.
Or are they saying
And it
you
makes
should
it a
know
lot
this to
easier.
review?
No. No, but some of the wording is going to be helpful with our pre-cal introduction to vectors. But the basics of what they're going to ask us to solve, it's not that deep, it's not that intense. For instance, the position vector is just going to be your horizontal position and your vertical position. And you can see kind of how this comes out of parametric equations talking about a horizontal and vertical. What's the velocity vector going to be? Well,
X prime of t?
x prime and y prime. Kind of like how we saw in the beginning with our picture. What's acceleration going to be?
So, right.
Another vector.
And jerk's gonna come into this?
No.
Thank God.
Jerk just means go one more time. Speed, now here's where it gets, and I want you guys to purposefully highlight star something or other. This is the most commonly missed topic, I think, having to do with vectors. This one right here.
The magnitude.
Exactly. Speed, absolute value of velocity, true, but when we're dealing with vectors, absolute value is magnitude. Meaning, not just how fast horizontally, how fast vertically, but if you're on a roller coaster, you don't care about the horizontal and the vertical, you care about the overall speed that you're going, putting everything together, which is going to be the magnitude of your velocity vector. And velocity vector we wrote down at the beginning of our notes. Remember, velocity can be broken down horizontal, vertical components of x prime and y prime. So then the speed in terms of vector will be the magnitude of that velocity vector. Which looks very, very similar to.
Just
Travel.
George.
How do we usually find distance traveled with velocity?
Absolute value.
Absolute value, the integral, right? The integral of speed or the integral of the absolute value. So kiddos, what would the integral of speed or the absolute value be in this case?
The integral of that. Whatever.
Wait, it would be our position.
The integral of magnitude?
With everything, yeah, that's very super.
It'd be the integral of the speed up above, right?
Yes. So
But isn't that the same as the thing?
that's arc length.
Which is distance traveled, because distance traveled will be the distance traveled on the path, right? So whether you're going forwards on the path or backwards on the path, that kind of makes sense. So we have T1 to T2.
Cosinus.
So the integral.
And if you want to work that out, flesh that out, that would be of above.
Wouldn't that be just arc length?
Which is, yes. Remember? We just said arc length because total distance is the distance you're going on the path, positive and negative doesn't matter.
I was thinking for some reason you'd have to find the area underneath, not the length of. That's why I said
Oh, got it.
So is vector homework due tomorrow?
that. No, it's Thursday.
Vector homework is going to be due on Thursday. We got a good bite out of it. We have displacement and then the magnitude of acceleration, as well as some examples tomorrow. Kiddos, grab some pie on the way out.